Pada penugasan ini, kami menerapkan struktur membran dalam merancang sebuah tenda untuk mewadahi pameran botanikal. Bentuk dari atap membrannya sendiri dirancang sedemikian rupa sehingga berbentuk menyerupai bunga. Konsep ini juga terrepresentasikan dalam maket kami dengan warna khas floral dan motif bunga. Pada tenda didesain berlubang di bagian tengahnya dan terdapat taman dengan kolam di bawahnya. Tujuannya agar taman menjadi kor dan air hujan dapat dialirkan ke situ.
External use. The coated fabrics most commonly used are PVC-coated polyester, PTFE-coated glass cloth, and silicone-coated glass cloth. They all offer different properties for strength, durability, translucency, and of course cost. By comparing these with the client's requirements, we can help decide the optimal material for any project. PVC-coated polyester scores well when measured in terms of its strength. It is easy to dismantle and print on, is relatively cost-effective, and requires moderate maintenance. However, it doesn't last as long and has a lower light transmission than other available fabrics. In contrast, PTFE-coated glass cloth offers durability, strength, and can be safe for maintenance. However, it is not suitable for demountable structures and is one of the more expensive fabrics we offer. PTFE-coated glass cloth is often used in harsh climates, such as desert environments, due to its ability to withstand high levels of UV and sound abrasion. Projects where light transmission is important, silicone-coated glass cloth is a viable option. Offering many of the same properties as PTFE-coated glass cloth, silicone has the added advantage of requiring little maintenance and offering high translucency.
Dena membran berbentuk segi 6 dengan sisi 20 meter dan rusuk 20 meter. Tinggi tiap kolom di setiap titik sudut segi 6 adalah 12 meter. Tinggi membran terendah, yaitu pada bagian tengah, adalah 4,5 meter.
Beban pada atap, yaitu pada membran, diasumsikan merata. Kemudian beban yang diterima disalurkan membran dan rusuknya dari titik tertinggi, yaitu kolom baja, ke tension ring dan kabel baja. Dari tension ring, beban disalurkan ke kabel pusat, kemudian kabel baja dan kabel pusat menyalurkan beban ke pondasi dan tanah. Gaya yang bekerja pada sistem struktur ini pada umumnya adalah gaya tarik, baik pada membran, rusuk, kabel, kolom, dan ring. Gaya momen terjadi pada hubungan kolom dan pondasi, sehingga hubungan kolom pondasi adalah jepit.
Struktur kabel adalah sebuah sistem struktur yang bekerja berdasarkan prinsip gaya tarik, terdiri atas kabel baja, sendi, batang, dan sebagainya, yang menyangga sebuah penutup. Struktur kabel merupakan struktur furnikular di mana beban pada struktur diteruskan dalam bentuk gaya tarik searah dengan material konstruksinya, sehingga memungkinkan peniadaan momen. Membran adalah struktur permukaan fleksibel tipis yang memikul beban dengan mengalami tegangan tarik. Dasar mekanisme pikul beban pada struktur membran adalah tarik. Membran yang memikul beban tegak lurus terhadap permukaannya dapat mengalami deformasi secara 3 dimensi, bergantung pada kondisi tumpuan dan pembebanannya. Selain tegangan tarik, terjadi juga tegangan geser tangensial pada struktur membran. Sistem membran pada bangunan bentang lebar biasanya masih harus dibantu oleh struktur lainnya seperti kabel atau space frame. Karena sistem membran bila terkena gaya dari angin, maka harus ada daya tarik menuju tumpuan pondasinya.
process of fabric architecture. Design. Every structure goes through its own design journey, whether it starts from a simple sketch or a more detailed architectural outline scheme. All structures require extensive design detailing to turn them into a final working plan. Designing a tensile structure is an art as much as it is a science. Throughout the preliminary design process, decisions are made on how the canopy will be constructed to meet the aesthetic, functional and engineering requirements set out by the project team. Decisions made at this point will affect the fabrication and installation methods. Boundary detailing is an essential element, falling into three main categories: curved or scalloped edges, straight edges, and fabric edges. A curved or scalloped edge generally consists of a cable enclosed in a pocket in the edge of the fabric membrane. The cables are held and tensioned at the corners by the membrane plates. In larger canopies, webbing belts are added parallel to the pocketed edge for reinforcement, but smaller structures may need no cable at all. As an alternative, it is possible to have an external cable connected to the edge of the membrane by a series of stainless steel link plates. Fabric under tension does not naturally form a straight line, so when a straight edge is required, the membrane is manufactured with a cader or beaded edge, formed by sealing a flexible rod in a small pocket. This can then be trapped behind an aluminium clamp plate, bolted directly onto the structural steelwork, or slid into an aluminium luff track extrusion. A fabric edge can also be curved and fixed with clamp plates or luff track. Such edges normally require flashings or cover plates to ensure the edge is waterproof. Engineering. Canopies can contain their tensile loads within their own structural framework, transferring the load into concrete foundations or ground anchors. Or they can transfer their loads onto an existing structure. However, the large lateral loads often require the structure to be reinforced. As part of the preliminary design process, a load analysis is derived from a computer-generated form-finding model. This provides the typical load size and direction. Then, incorporating a factor of safety, an engineer will determine the design of the supporting structure, the size of the foundations, the required material strength, and the necessary tension. The boundary details are then engineered to maintain the tension and accommodate the movement that may be generated at the canopy extremities. In many situations, consideration for the load that snow will impose on a structure is equally as important as considering its ability to withstand strong winds. With the added risk of snow drifts, we have to be mindful that this can lead to water ponding. For areas where heavy snow load can be expected, structures are generally designed to have smaller spans and a greater degree of inclination to encourage the snow to slide off. When designed appropriately, fabric structures can withstand the most extreme weather conditions. Manufacture. Unlike traditional construction materials such as brick and concrete, one feature of tensile fabric structures is that it can be entirely manufactured off-site. Large clear span spaces are required for the fabrication of tensile structures, as the surface area of a single piece can reach hundreds of square meters, although we are usually limited by the weight of large membranes more than the size.
At the point of design, we go through computer modelling, analysis with form finding, patterning of the material. After patterning, the basic fabric form shape is taken to the cutter plotter, which is behind me, is cut and then welded together.
Using such a wide range of fabrics, it is necessary to adopt a variety of manufacturing methods to cut and join tensile fabrics. These range from advanced sail-making techniques to more industrial large-scale manufacturing processes. Welding works for the majority of our fabrics and is suitable for external use. Some fabrics are joined by radiofrequency welding. This consists of heating the thermoplastic element in the fabric coating using electromagnetic waves to soften them and bond the two layers together. Advanced welding technology allows us to create an even strength across the length of the weld and a bond which will withstand extremely high tensile loads. Not all fabrics can be welded easily, and some require an additional layer of bonding tape to ensure the weld can achieve the strength and stability requirements for this type of application. The seam is designed to have the same tensile strength as the fabric itself. Sewing is suitable for smaller projects, and for reinforcement patches on some larger membranes, we use industrial sewing machines and UV stable thread to join the fabric layers to one another. For some applications and some types of fabric membrane, including silicon-coated glass cloth, welding or sewing are not an effective means of joining. Gluing using a high bond adhesive will provide a joint with adequate strength and durability. Installation. As the majority of manufacture occurs off-site, the installation of a tensile fabric structure is fast in comparison to other building materials. Designing and manufacturing tensile structures which are practical for erection is essential. Therefore, components, connections, tolerances, weight and sizes are all considered from the early stage. Installation of a tensile membrane requires an understanding of the material and its behavior. During the design and fabrication process, the membrane is tested and patterns adjusted to compensate for the inherent stretch in the fabric. When first delivered to the site, the membrane is smaller than required and only takes its intended size and form once tensioned into place using one of the many erection methods we can adopt. The skill and coordination of site operations are critical to the success of a project. Technical knowledge and experience of the construction and installation process often involves potentially high-risk operations, with demanding access requirements or complex lifting operations.
There's two main skills that are required from site crews: is safety and also competence in the work that's being carried out. Safety is paramount. All our installers are qualified rope access technicians. They've all got extensive experience in the use of mobile plant and working at height. The other requirement is that they're competent in the installation of fabric. Various different fabrics handled in different ways. PVC, PTFE and ETFE are all handled in different ways.
Depending on the type of canopy or structure being installed, installation methods can vary. Some structures have masts which are hydraulically jacked up or extended with a telescopic section in order to tension the membrane and support the structure. Smaller structures can have corners pulled out with rigging screws, U-bolts, or by shortening the perimeter mast to tie back cables. Individual scallops can also be tensioned by shortening the edge cable where it connects to the membrane plate. A very common method is to pull panels into parallel luff tracks and tension by drawing out the corner plates that slides inside the luff track.